we should introduce our friends here. We have some new guests today. This is Squish Brain, as you can see. He's nice and squishy. And once again, this is Binary Brain Bob and Stink Owl, woo woo, and Boney McBone. So today we're going to start talking about the exciting notion of vector dot products. And this is what's going on. Suppose you have two vectors, u and v. We'd like to have something that's like multiplication. So we call this dot, and it's not really multiplication, and we're going to get into what it is. But I have a couple of problems that are at the tail end of the last lectures that I don't really want to tag on. So we'll just start. These are very, very often seen vector problems in physics and your test that's coming up. So I'll just go right to that. We'll get the dot products probably in the very next one. So homework / test like question. An object is acted on the origin by two forces, u and v, with angle theta u and theta v respectively. Find the direction and magnitude of the resultant force. Okay, so the information we have there given us is the force u, or the vector u, is 30 pounds, and the angle of u is at 0 degrees, and the vector v is 90 pounds, which is a force incidentally, and the vector, or v, lies in the direction of theta equals 60 degrees. So let's try and draw a picture of that and see what they're talking about. Incidentally, one of the amazing facts about our reality, or it appears to be, is that it's called superposition. It means that you can take all the vectors that are acting on an object and add them all together in their components, and they add just straight up, and the answer comes out right. It's really amazing. Quantum mechanics, the superposition principle is one of the founding principles of it, and it makes all the neat, weird stuff happen. That and its linearity. Okay, so here's the deal. We have this box. I'm going to pretend that the center of mass, or all the action is happening with respect to right here, just because it's my coordinate system. If I wanted to, I could square up the box here. In general, in physics, we find the center of mass, and we make all the vectors taking off from that point. But this should do fine for this representation. So u is 30 pounds. This isn't scaled. It doesn't matter. So I'm just going to I need a picture to get my idea. So here's u, and this is 30 pounds. Notice it's theta is 0, so we know that this is 30 pounds I plus 0 pounds j, right? Because the angle's, it's 0 like this, right? This is 0 radians, which everybody in this class knows that. Now we know that v is 90 pounds, and it's up at 60 degrees. I will attempt to make this look somewhat correct. And this orange is not doing so well today, so I guess we will go with red. Okay, so this is V, and this is 90 pounds, okay? And in this direction, and this is 60 degrees, this angle right here. So basically what we want to do is break this down into components, which U already is. So V, we know component-wise, the norm of V, and actually this is a little wrong. This is the norm of V, because remember a vector should be written as AI plus BJ. So the norm of V is 90 pounds. It's just its numeric strength, so to speak, and it's at 60 degrees. So let's figure out what V is. Well, V is going to be, and so here's our triangle that we're using, the jth component, here's the ith component. So we know that this is going to be the norm of V times cosine theta V I plus the norm of V sine theta V J. And all I've done is taken the magnitude, I'm taking the sine of 60 and multiplying it by that to get this particular aspect. Once again, why? Okay, so let's remember very quickly then why that is. Here's theta v, here's the norm of v, which in this case is 90 pounds, but I don't need any number. Here's the jth component, and here's the ith component. And these are just the scalars. We already know what's in the I and j direction. This is why we're calling it the component. And you'll learn later today about projections, which are the components times the unit vectors, but we'll get on that. So we know that the cosine of this angle is going to be the ith component divided by the norm of v, which is the same as the norm of v times cosine theta. And then here's the I, right? This is a number. This is the vector, the unit vector in the direction. Similarly for sine, it's going to be that for the jth component, we know that the sine of theta is the jth component divided by the norm of v. I should have my little bar there, which means that this bit right here is the scalar in front of the unit vector j. I suspect everybody's okay with that, or if you're not, you're starting to get okay with that. So here's the great thing. This is called superposition. We can take these and add the components. So what it's going to be, the resultant vector on this will be the sum of these two vectors. I suppose I better figure out what this is. So this is, well, what do we got? 90 lbs. The cosine of 60 degrees is 1/2. Hopefully everybody knows that by now. I plus 90 pounds times the sine of 60 degrees. This is the square root of 3 over 2j. This cleans up. This is, so v is 45 pounds. I plus 45 times the square root of 3 pounds j. U, we already know, is, what do I got? 30 pounds I and 0j. 30 pounds I plus 0j. So we're just going to add them in columns. The resultant force, or the resultant vector, is just adding these vectors. Now what we could have done is add vectors. How do you add vectors? Well, if it's going to be this plus this, we can take the tail end of this and put it up here, like this, and then draw this up to it. However, you really can't figure out stuff about airplanes and how far they'll fly on a tank of gas by drawing pictures. You really need to use the mathematics. So the resultant vector, which I'll call capital R, is going to be 45 plus 30 pounds, which is going to be 75 pounds I, plus 45 square root of 3 pounds j, right? And now let's figure out, okay, so that's the actual vector. What is the resultant scalar force? What's the number? Like V was 90 pounds at this angle. What's this? And so we find the norm of this in the usual way. It's going to be this squared plus this squared square root. So this is going to be 75 squared plus 45 square root of 3 squared square root. I actually did this so I wouldn't spend a billion hours on the calculation. This is 108.17 approximately pounds. Similarly, what's the direction of this? Well, remember the direction angle, the tangent of whatever angle this is, we'll call it R, is the y component divided by the x. So that means that the arctangent of the y component divided by the x, remember R, oopsie, wrong R. R can really be written as this. This is 75, 45 square root of 3. So my producer tells me we got just a couple seconds. We'll catch this on the next one.